Hey everybody, this is Larry. This is me going Q3 of the weekly contest 390 most frequent IDs. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem in the comments, and yeah, let's get to it. This one, I think it's just a data structure problem. I think there are a couple of ways you can write this, but what I would categorize this as, and I know that people, I don't know that people call it this because every time I call it this, people ask me in the comments because it doesn't show up on Google or whatever, or as much. Maybe it does now. I don't know, because I've been saying it for a couple of years now, and I feel like my word kind of gets spread out there eventually. But I call this a bookkeeping problem, right? And the reason why I call it a bookkeeping problem is just that you have a couple of things, and you try to make sure that when you update a thing in one place, you update it in all the entire things, and then but the collection of the data structures that you have will give you, the state of the world as it evolves over time. So you have to kind of like bookkeeping, like with an accountant, you have to make sure that everything is cross-referenced and to each other in some, I don't know, I feel like I'm dancing like conspiracy theory or something. But yeah. And for this one, I in different languages it could be different things. So I don't know all the other languages, so my apologies, but I'm gonna go with Python. But you can also use like in C++, you could probably just use like a map or something, right? Where you just get the not a map, but like like some sort of ordered statistic tree. No, not even maybe just like a pair or something, right? Or like a set that is in a pair or something like this, right? So that you could get basically something that you get the biggest element, but because basically what it wants is that it wants the biggest element by the count the most frequent, but also things that let you remove elements, which is important because you have to do updates, right? So that's why like a heap is not, or the heap that is in libraries is not good because of this reason, where if you do your own heap where you could do updates, in the hypothetical sense that, in the theoretical sense, those kind of heaps you can use it, but it's not, readily available in libraries. So yeah, so here I use a sorted list in Python. It's just basically what it sounds like. It's a list that is sorted, but the most critically important for us is that it allows us to get the max element, right? If you use it correctly. And here we keep track of two things: a sorted list and a frequency lookup table. And then now I do a for x and k. I don't know why I wrote x and k, but yeah. So here, if x is not in f, then we set it up, right? We create a new element. We set it equal to 0. I know that there's a default thing, but just want to make it explicit. But we also want to add it to the sorted list. And in my sorted list, it contains the count of the element, which is 0, or the frequency of the element, which is 0, and then the element itself. So this is kind of sorted in that way. It's sorted in a pairwise, or in a pairwise, tuple-wise function, or what, I don't know, but basically key by key in order, right? So it's going to sort by the first thing and then the second thing. The second thing doesn't matter as much, but the first thing matters. I think you don't even need it per se if you really, because I think you can also just remove and then add, and then it'll be fine. It doesn't matter what the value is, but I like to do it this way just to kind of, especially during a contest, because you don't want to prove anything. I think you can actually prove that you don't need it as I see it now, but when I'm writing it, I don't know. Who knows, right? But yeah. And then now I remove, this is the update, right? So an update, you can model it as a removal and then an add. So this is remove, so it gets rid of the old item, and then it just doesn't add to the frequency, and then now it adds the updated frequency. And that's pretty much it. We just get the biggest element. If the length of the sorted list is 0, we append 0. Otherwise, we just return the biggest, the most frequent element, the thing that is sorted by the first element to last, the biggest, and then just get the value of that one, and we append to the list. And I was thinking about doing this during a contest, but you can actually add a sentinel value. But I didn't want it to risk like this would be a really stupid mistake to make, right? Like if I get a wrong answer because I had a typo here or something like this. So you could have actually done it this way, add a sentinel value for like an infinite value, and because of that, then like this will never be happen, but the biggest element will always have at least one element, and it will always be 0. So that should be good as well. Yeah, I'm going to try it. So yeah, what's the complexity here, right? So the complexity here, as you can see, sorted list, let's just say, this is log n. So if this is log n, then we do 3 log n operations at most, which is going to be O of n times log n, right? We have O of n, is it n? I guess q, depending how you want to say it. Because all right, let me start over, because I think I'm confusing n and q. They call it n, but I think they're 2 different things, right? So n is the number of unique elements that we ultimately put on the sorted list, and q is the number of queries that are in the input. Then this is going to be q, O of q log n. Ooh, what happened? I think I pressed the wrong button. Sorry. Time, right? And this is O of n space, where n is again the number of unique elements that comes as a result of these queries. Yeah, and kind of the beauty of, I think I'm kind of skipped over something because I don't need to, is that you can also add and removal. But as you can see, because of the way that we kind of structure this, we can add and remove. I don't have to special case it because k is negative, right? So yeah, the only thing that I did double check is that the input cannot be negative, because otherwise it just, I don't know. I just wanted to see if I have to handle it specifically. More than that, like I could imagine there's a problem, maybe not this one obviously, but a problem where like if it goes to negative, you have to set it to 0, then you have to do some like other stuff, right? But yeah, otherwise this is the problem, and that's all I have for this one. Let me know what you think. And you could watch me solve it live in the contest now. Makes sense. I am dumb. All right. Okay. That was a little bit slow, but okay. Norms and frequency of equilibrium. What does that mean? To count the most frequent ID. And this is, people got very fast. I don't even think I understand this part. Okay, so 2. Oh, just sort the list, right? Can you remove more than? Okay, yeah. Okay, fine. Right, so if x and f, if x not in f, x is 0, 0, so dot add most frequent. Okay, right. And then now this. Three 201. All right, let's go. I have to find a button to click on it. Oh wow, people are already. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord, leave a comment about what you think about this poem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.